Hello, so today we are going to do this problem 3 sum closest, which is part of Leetcode daily challenge. So the problem says we get an array of numbers of length n, and we get a target, and we want to find the 3 integers such that their sum is the closest as possible to target. And what we want to return is the sum of these 3 integers, the sum that is closest to this value target. And you can assume that we can have only one solution. We have exactly one solution. So let's take a look at this example with target equal to 1. The closest one to this value is the sum 2 of 2 numbers, which is this here. So minus 1 plus 2, that's 1, plus 1 is equal to 2. So that's the closest one. If you try, let's say 2, 1 minus 4, that would be minus 1. So same difference, right? Two difference, and no matter how you do it, right, this is the closest. If we take a look at this example here, the sum that is close, there is only one possible sum of 3 numbers, which is all 3 zeros, so we return that sum, right? So that's the idea. Now let's see how we can solve it. Okay, so let's see how we can solve it here. So this is what we can do. Is first thing to notice is that there is no constraint on like the 3 numbers having to be contiguous, right? We can choose any 2 numbers. So for example, in this case, we can choose this one, and this one, or we can decide to choose this 2, minus 4, and maybe minus 1, right? So the numbers don't have to be contiguous. So with that, maybe we can sort and then use that in our advantage. So we can sort the number and see how we can take advantage of that. So if we sort, then the solution actually becomes easier because we can just use 2-pointer technique, and depending on how close that sum is to the target, we can decide whether to advance to the left side or the right side. Let's see how that pans out. So let's say, for example, this array here, if we sort it, what do we get? We get minus 1, minus 4, minus 1, 1, 2. Okay? So what we can do first, we just take the first smallest numbers, and assign our best value to that. So that would be minus 4 minus 1, that's minus 5, plus 1, that's minus 4, right? And what do we want to do? We want to start I from some index, right? I is the first number of the 3, but I needs to go only up until n minus 2, right? So up until here, right? Because you can't go past this to have 3 numbers. If you go here, you can't have 3 numbers anymore, right? But actually I'm realizing this is too small of an array, so let's pick a larger one. Maybe let's say something like minus 4, minus 1, after it's sorted, 2, 3, 7, 9, something like this. And let's say maybe k is equal to something reasonable. So the closest one to 5 would be, or maybe let's say 9, right? So the closest one to 9 would be minus 1 plus 1, that's 0. Let's make this one 5 here, so that solution is valid. Okay? And let's say this one here is 5. Okay? So once we sort, so the best is equal to minus 4, right? So our I initially is here. We can do 2-pointers technique, because we can place the left side at I plus 1, place the right side at the end of the array, and just do the sum. So the sum here would be minus 4 minus 1 plus 9. So this would be minus 5 plus 9, which is 4. Okay? And so we compare that. We get the difference between that and the target. So what's 4 minus target, which is 5? That's minus 1. So what can this tells us about moving, which pointers to move? So if diff is equal to 0, well, that's the best answer we have. So we can just return, because that means it's equal. The sum is actually equal to target, and we can't do better. So if it's equal, then we can just return the sum. Let's call it s. But if the sum is smaller than 0, what should we do in that case? So if the sum is smaller than 0, that means s is, so s minus target, the difference, sorry, is smaller than 0. That means s is smaller than target. That means if we want to get a number that is closer to target, we need to increase s, right? So that it gets closer to target. So that means we need to advance our left pointer. So here we advance our left pointer. If it's, in this case, diff is bigger than 0, what does that tell us? So that tells us that s minus target is bigger than 0. Okay, which tells us that s is bigger than target. So to have a chance to have a better number or closer number, we need to reduce s so that it gets closer to target. How do we reduce s? We get a number smaller than the right one. To do that, we go right, and so we decrement our R value here to be able to do that. So you can see this makes it quite easier. But in each step, because we are taking the absolute value, we actually don't know if we decrease that that would be the best solution. So each time we need to keep track of the best so far. So we say the best should be equal to s if the absolute difference between the best minus target is bigger, right, than the best using this s, than the difference using this s value. Okay? But otherwise, if it's not bigger, if it's smaller, then it means best is still the best answer. So we just keep best here, right? So that's pretty much the idea. We sort the array first, we get the 3 first numbers, and then we use 2 pointers technique, and depending on the difference between s and target, the sum of the current 3 numbers and target, we decide whether to move the left or right pointer. Because with these, it tells us that what should we do with s? Should we increase it or decrease it? And depending on that, we move L or R pointers. And we should do this while, of course, while left is smaller than R, because once they meet, let's say maybe they met here, we are done. There are no more numbers to look at. We already explored our numbers, so we should stop and just return the best we have so far. Yeah, so that's pretty much it. Now, in terms of time complexity for this solution, we'll be going through every I, right? We'll be moving I for every time, right? So once we are done with LR, we want to keep moving, because when we get an answer for I here, that's the answer for I fixed at this position. But maybe the answer, like in this case, is when I is fixed at this position, because -1 + 1 + 5. So we need to do a loop for I, so that, because we fix the first number and then we do this 2 pointer technique to find the 2 remaining numbers. So what this tells us is we have a first loop for I, which is O of n, and then we have another loop for the 2 pointer, which is also at most O of n. So overall, this is solution is O of n squared time. Now, in terms of space, we are not really using any extra space. We are using 2 pointers and then a loop, so it's O of n space. So that's kind of the outline of the solution. Now let's implement it and see if it passes our test cases. Okay, so let's implement the solution we just saw in the overview. So first we said that we want to sort. Then we want to keep the best numbers to be the sum of the first 3 numbers, right? And then we want to fix I each time, but it has to be at least up to n-2, because otherwise there are no more 3 numbers to look at, right? One optimization I'm going to do here is if there are duplicate numbers, we want to skip them, right? So if this is equal to I-1, right, then we want to skip. Yeah, this is just a small optimization, but the core of the thing is we want the left and the right side to be I + 1 and right side to be the length of -1. So this is just skipping duplicate numbers. And here, so we do, we fix the left and the right side to I + 1, and n minus 1, right? And then we start moving them while they are different. So while the L is smaller than R, what do we want to do? We want to say the current sum, right, is equal to the sum of the three numbers. So we fixed I, and then we have the two other numbers are L and R. And the difference is going to be S minus target, right? So if this is equal to 0, that means we should be able to just return S because they are equal. But if diff is smaller than 0, so that means basically S minus target is smaller than 0, which means S is smaller than target, which means we will do best by increasing S. And to increase S, the only way we do that is by increasing L so that we explore bigger numbers, right? We add a bigger number here. If we decrease R, we will add a smaller number, so that won't be beneficial. So we increase L. But if diff is bigger than 0, which means S is bigger than target, so in this case, what we want is to decrease S, sorry. And to decrease L, we need to add a smaller number for R here, so we need it to decrease R. And here we can just do else instead, and this would be basically when diff equal to 0, so we have our answer. And for each solution, we want to update our best value, which is going to be S if this is better actually than the previous the previous best we have. So if this is bigger than the absolute value for S minus target, which is just diff. So if this is bigger, that means this is a better solution because it's closer. That means S is closer. Otherwise, we just return best. Okay? And then at the end here, what we want to return is the best we have so far. Right? And note here, we fix every I, and then we move L and R. So let's run this. So invalid syntax here because we don't need this semicolon. Okay, let's submit. One thing to note is that Leetcode has been having some problems with Python 3 recently, so some solutions that used to pass no longer pass. So hopefully this one will pass. Okay, yeah. This is a reasonable solution because if you take a look at the constraint here, this is O of 10 to the power of 3. So O of n squared is going to be 10 to the power of 6. So it should pass. And you can see here in the second run it passes. So this, yeah, Leetcode has been having troubles with this lately, but yeah, this is a good solution here. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.